Calculus by James Stewart. I haven't purchased this book, but I purchased as many as 4 copies, 4 hard copies, 4 hardback copies. This is now my favorite book. From this book, chapter 16.7, Surface integrals, surface integrals. Scroll down. I assume you have read oriented surfaces or surfaces. Scroll down. We will discuss surface integrals of vector fields. Vector fields, flux or flux. I assume you have read the text here. Scroll down. We will be solving example 4. Find the flux of the vector field F across the unit sphere. This is our pretty sphere. Today is February 9th, 2023. This is my 222nd episode for C++ 17 2023 Coda School Book OpenGL TBB Balkan. This is my 52nd episode for vector calculus. This is surface integral 11. We will learn surface integrals of vector fields, flux. If you do not have up-to-date C++ library extensions, you can download by clicking this link. I will update my library in the current session. After filming video, you may click this link to download updated C++ library extensions. Without further ado, let's get started. Open up Visual Studio Code. CPP 17 2023 parallel. Select empty space. Click this button. 222 Flux. Click this button. Flux.cpp. Hit enter. Ctrl V. I will delete welcome document. Then drag and drop Calculus James Stewart. Move to page 1190. We'll be solving example 4. I will arrange side by side like this. I would copy and paste these things for my own reference later. I will also copy and paste these things into main, copy, solve example 4 here, semicolon. Now we need to define or parameterize this unit sphere as a vector. Auto R CNA create BCTR3D. We need to parameterize this unit sphere like this. Auto P auto theta. Return SCD sine P times SCD cosine theta, comma, paste. This is sine theta. This is cosine phi. Here, phi is for polar angle. Theta is for azimuthal angle. This is for x component. This is for y component. I misspelled. This is for z component. Remove trailing comma. So these are parameterize our unit sphere, as in figure 12. So we created sphere. Now we need vector field. Again, auto app CNA create vector semicolon auto x auto y auto z. Here we return z. Return z. I will remove the carriage return. Copy, paste. Now we return y, this y here. Then x here. Remove trailing comma. Please observe, in case of vector R, member elements takes 2 parameters. In case of vector F, members take 3 parameters. Then how can we operate R and F? That's very easy. See, F, we put R, vector R. Okay, look at my hand. For such purpose, auto F over R, CNA, create VCTR 3D. We capture F and R. Auto phi, auto theta, comma here, auto x. R, evaluate x. Phi, theta, copy, paste. Y, z, return F, evaluate x, y, z, copy, paste, remove trailing comma. Here we have to return evaluate y. Here we have to return evaluate z. Up to this point, we implemented f of r. Now we have to evaluate r phi, r theta, then cross product. Or r phi, r theta from r derivative, or dA rp. This is cross product rt. We performed cross product as in this document. Now we need f dot rp cross r theta. We can do like this, or integrand f over r. This is dot product dA. dA is rp cross r theta dA. Then or a CNA integral. We pass integrand here. Then STD make tuple. We are integrating over this sphere. So 0.02 times 5. This is theta limits or azimuthal angle. SCD make tuple 0.05. phi with or polar angle d phi dt because limit for phi comes later than the limits for theta, like this. Oral answer. In this book, the answer is 4 pi over 3. 4 pi over 3. Cine print answer. A answer. Now open up any compiler. dir cd 222 Flux clang std c++ 20 flux.cpp ltbb12 or c.exe hit enter. Scroll up. Dot is ambiguous at line 126. At line 126, dot is ambiguous. It says CPG vector 1047. Control Home, right-click Calculus, go to Definition. CPG vector, go to Definition. Control G. 1047. So this operator is ambiguous or conflicting. I will fold them up from here up to this point. I disabled. We build again. It is still conflicting. Now with 1445. Control G 1445. I will disable this function. We rebuild. CLSC. Our computation is correct. I will fix this part sometime later when I gain more experience.